We all know that our universe began with the Big Bang. Well, almost all of us. There are a few flat earthers out there who think the universe is actually just a disk with a North Pole in the middle and the South Pole is where everything goes when it gets too cold. But for the rest of us, the Big Bang is where we came from. We've been taught this in school. It's what most scientists agree on, and it can be observed through the cosmic microwave background radiation. But what happened after the Big Bang? If the entire universe was created at once, then shouldn't everything have started out right away? Why did it take so long for stars to start forming? To answer this question, let's take a look at what may have happened in the first second after the Big Bang. It's hard to believe. But in the fraction of a second following the Big Bang, our universe went through more change than it had in the billions of years prior. During this time, the universe was changing at an unimaginable rate. Our sun, which is 400 times larger than the Earth, would be reduced to the size of an atom. During this time, space itself was being created. Space continued expanding for millions of years at this same rapid pace. And still today, it continues to expand, albeit at a slower rate. The reason why our universe is expanding is because of something called dark energy. We really don't know much about dark energy, other than the fact that it makes up 68% of the total mass of the universe. In the first second, the particles that make up our matter began to form. These included protons, neutrons, and electrons. But these particles weren't floating around freely. They were moving at incredible speeds and smashing into one another. This is also the time period when the Higgs boson was produced. The Higgs boson is what gives particles their mass. So without it, the particles wouldn't be able to form into anything that we recognize. As the particles continued to move around, they began to slow down due to the newly formed Higgs field. As they slowed, they began combining. First, the protons and neutrons combined to form atomic nuclei. Then the electrons were added, and the first atoms were formed. These were mostly hydrogen atoms, but some helium and lithium atoms were also formed. And the amount of these three elements is what we see in the universe today. That is because after this first second, nuclear fusion stopped. So how do we know all of this? Scientists have used computer simulations to reconstruct what they believe happened in the first seconds after the Big Bang. The simulation shows the movement of the particles and how they interact with each other, and by using the laws of physics that we already understand, scientists can make a pretty accurate prediction of what took place. But now, here's the big question. If everything was made in the first second, why didn't it all happen right away? Well, even though the fundamental particles were created right at the beginning, they didn't stay that way. They continued to move around and collide with each other. If they hadn't done this, then the universe would have looked like a huge explosion. Everything would have started flying off in every direction. Instead, what we see is that everything began to slow down and come together in a process that took hundreds of thousands of years. Eventually, gravity caused everything to collapse in on itself, and the first stars and galaxies began to form. But there is a mystery that scientists have yet to solve, and that is what caused the expansion of the universe to slow down. If the universe had continued expanding at the same rate that it did in the first second, then nothing would ever have come together. Gravity wouldn't have had a chance to take hold, and our solar system, Earth, the galaxies, the stars, none of it would have ever existed. In fact, the entire universe as we know it would be nothing but hydrogen gas floating around in darkness. So why did the expansion slow down? Some scientists believe that the answer lies with inflation. Inflation is the idea that our universe expanded at a much faster rate in the first few fractions of a second after the Big Bang, but there's no evidence to support this theory. And the main reason for this is because we can't look back that far. The further back we try to look in time, the further back we're looking in space. This is because light takes time to travel. So the light that we see coming from distant stars is from when the star was brand new. It's from right now. The only exception to this is with gamma-ray bursts. A gamma-ray burst is the explosion of a star. So when we see the light from these explosions, we're seeing them as they happened. Gamma-ray bursts are the most powerful explosions in the universe, and they're also the most mysterious. We still don't know what causes them to occur, but they do help us look back in time. The light from these explosions is so bright that we can see them clearly, even from very great distances. Using this, astronomers have been able to identify gamma-ray bursts that occurred over 13 billion years ago. This means they've been able to look back in time 13 billion years. And while this is extremely far, it doesn't go back far enough to help them understand what happened in the first second. Another thing that scientists are trying to figure out is what happened to the antimatter in the first second. Matter and antimatter are exactly the same except for one thing: they have opposite electric charges. Antimatter is negatively charged, and normal matter is positively charged. When matter and antimatter meet, they annihilate each other and release energy. This is what powers many of the particle accelerators that scientists use to study the fundamental nature of our universe. But back in the first second after the Big Bang, there should have been an equal amount of both matter and antimatter. Scientists have a couple of theories. One is that all of the antimatter in the universe was destroyed during the Big Bang. Another is that the antimatter formed into antimatter stars, and then they flew away from our part of the universe. There's also a third theory that says that the antimatter never existed in the first place. But which one is correct? Scientists don't know. One final thing that scientists are trying to figure out is, where did the first stars form? We know that they formed out of clouds of gas that eventually collapsed in on themselves. But where did those gas clouds form? Was it in the same place that our solar system formed, or was it somewhere else entirely? These are the kinds of questions that scientists hope to answer in the next few decades as technology improves. When we think about the first second after the Big Bang, it seems like such a short period of time. But when we consider that the entire universe was created in that span, it becomes clear that it was one of the most important times in history. Without the events that took place in that first second, our universe would be a very different place today. If you enjoyed this video, then make sure to check out my video on what happened before the Big Bang. Unfortunately, I have to warn you that we currently don't know what happened before the Big Bang. And that's the reason why I didn't upload a video last week. It's kind of hard to talk about something that we don't know. Anyway, if you want to hear me ramble on about absolutely everything, then make sure to check out my podcast. We talk about everything from science to philosophy to current events. Thanks again for watching.